In this video, we are going to get a lot of practice using the central limit theorem and the calculator work, and also we're going to learn about the sum of averages. This is going to be kind of a cool little trick we can use with our calculator to find some new types of story problems. So here we have a study done about violence against prostitutes and the symptoms of the post-traumatic stress that they developed. Now the age of the prostitutes was 14 to 61, which actually is kind of good for solving some of these problems because we can use some of these values instead of negative infinity and positive infinity if we want to. But generally speaking, we're not given the range of the sample group in our story problem. So this sentence, the age range, isn't really relevant to a lot of the problems that you will be doing in your homework, but it is kind of nice to actually see where we could have used this with the technology. Now, the average age was 30.9 and the standard deviation is 9 years. These are very important facts, and we'll highlight these. So I like to indicate them just in the problem itself, just so I know where I'm at. And this is going to be mu, and this is going to be the standard deviation. Now again, we will have to modify the standard deviation based on the type of problem we're looking at. So here it says, in a sample of 25 prostitutes, so n equals 25, what is the probability that the mean age of the prostitutes is less than 35? So here's what we're looking at. We're looking at the probability of x bar, and we're looking at x bar because we have n equals 25, is less than 35. Okay, and this belongs to the normal distribution, and we are going to be using the average of 30.9 because my mu is equal to my mu of our group X, and then our standard deviation is going to have to be modified because our standard deviation is going to be 9 divided by the square root of the sample size, 25. And that's the standard error of the mean right here. And we do that when we have a larger sample size than 1. So in the calculator, we're going to use our normal CDF for our continuous distributive function. And we are going to go to, since we're going less than 35, so again, we're looking at a situation where we're going to be less than 35. This would be an open circle since it said less than. I'm sorry, it looked closed right here, but this means we're going to go to negative infinity. Now, another way we could put our minimum here as 0 or 14 if we wanted to, but just to keep with all the problems that we've been doing so far, we're going to go negative 10 to the 99th power, just because we're going to statistically go less than negative 35, up to 35. And then we are going to use 30.9, this is my average, and my standard deviation is 9 divided by the square root of 25. And if we type this into the calculator, we will get the right answer. So we will go second vars, and then go to normal CDF, hit enter here, and it looks like my lower bound is already in there. And if you were wondering how you would type that in, you would type in negative 10 and use the caret key and 99. This would get us to negative infinity because we wanted less than 35. The upper bound is 35. Our average is 30.9. And our standard deviation is 9 divided by the square root of 25. And then hit enter and paste, and that will put that right in there for us. And this gives us an answer of 0.988, or 989 if we rounded to 3 decimals here. So here we go, we got an answer of 0.989. So therefore, we use 3 dots like bowling ball holes. Therefore, we have a 98.9% chance that the average of the group is less than 35. Highly likely, highly likely. And that's also probably because we're including a domain that includes the average, which is 30.9. Now, is it likely that the mean age of the group could be more than 50 years? Interpret the results. All right, so what we're looking at is the probability that x is greater than 50. And the reason why I want to do this problem is because your calculator might spit something out that you may not be familiar with. And so, again, we're going to have n. Oops, my n is in the wrong place. I'll put the n on the outside of the parenthesis. Okay, n 30.9. 9 divided by square root of 25. Now what's nice is that your calculator has some of these values loaded into it now. And since we're looking at a situation where we want greater than 50, so here's 50 and we're going to go to positive infinity here. So we're going to go normal CDF. And this is when we would go from 50, which is our lower bound, up to infinity. Now we actually could use 61 here if we wanted to, because this was our range of our group. And for this problem, it wouldn't change anything. But we're going to go 10 caret 99 to get us to positive infinity. And then we'll go 30.9, and then 9 divided by the square root of 25 for my standard deviation. Okay, so then go back to the calculator here. Let's click on second vars and then go down to normal CDF. And we're going to go from 50 to 10 raised to the 99th power. And everything else is set up fine. And now we get an answer of 1.3 e negative 26. Now you might think that that's 1.3%, but that's not true. So what I need to kind of show you is that 1.3 e negative 26 is 1.3 and the decimal is moved 26 spaces to the left. So you're going to need 25 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sorry, 21, 22, 23, 24, 25. Okay, so there's 25 zeros, 1, 3, because we moved the decimal 26 spaces to the left, which would give me 25 zeros. That's a very small number, so it's 0, 0%, because it's very unlikely, even if we move this back 2 spaces here, it's still 0%. So, is it likely? No, not very likely. And so there's a 0% chance that your average of your 25-person group is over 50. All right, so we're going to learn something kind of new here, and this is a little exciting because what these next two problems are going to do is it's going to talk about the sums of the ages, the sum of ages. So you see in this problem and this problem, the sum of ages. Okay, so what that means is that we want to add up all the ages of the people in our sample, and our sample size is changing, so this is important because we have n equals 49 here, n equals 49 here. Okay, so it's important to notice that during the problems they can kind of change up the sample size ID, so be aware of that. So it says here in a sample of 49, what is the probability that the sum of the ages is no less than 1600? So the probability, and we are in this case looking at x bar, okay, but this is the x bar of this is the sum of those sum of that group right there. So, and again, I'm putting the sum symbol in there just as an indicator of what we're doing. This may not be the most accurate way to write this down, but I want you to be able to distinguish this by looking at the problem. So the probability of the sum of x bar is no less than, so that means it has to be greater than 1600. Okay, because we don't want anything less than this, so we can actually even include that if we wanted to. This isn't really the critical part of the problem, but it's just setting us up for this n. And this n for the sum of ages is going to change the average a little bit, because instead of just using the average, we now are going to multiply the sample size times the average, because if we're looking at the sum of the ages, we need to take each age and multiply by our sample size. So that needs to be an adjustment there. Also, The standard deviation isn't quite the same. We're going to take our standard deviation, and instead of dividing it by the square root of the sample size, we're going to multiply it by the square root of the sample size. So it's a little different when you see sum of the ages. So actually, let's just quickly do a little plug and chug here. Our sample size is 49, and our average is going to be 30.9. And we can let the calculator do this work. We can just type this in where that belongs. And the lowercase sigma here, this is going to be our 9, and this is going to be times our square root of 49. All right, so in our formula, we're going to have normal CDF, emphasis added there. And then we're going to go from, let's see, 1600 to positive infinity, because we're going from 1600 in this direction. So here's 1600. We're going to go to infinity. So this is 10 caret 99. And we are going to put in our average here, and our average is going to be 49 times 30.9. And our standard deviation is going to be 9 times the square root of 49. And if we do this, we will get our answer. So, getting our calculator ready, go second vars, go down to normal CDF. Okay, so my lower bound is 1600. Looks like we have our upper bound from the last problem. Now our mu is going to be 30.9 times 49. You can do that in any order, thanks to commutativity. Now we've got 9 times the square root of 49, which I know is 7, but I can just type everything in and let it paste in the function and get an answer of only 8.6%, or 0.086. 0.086. So 0.086. Therefore, there is an 8.6% chance that the sum of the x bar is greater than or equal to 1600. All right. Wow. There is, again, that sum of symbol isn't necessarily the exact super perfect way to write that, but it conveys the idea that we're looking at the sum of ages rather than just just the ages of the group. All right, because no one person is going to be 1600 there. All right, so now we have a similar problem here. Is it likely that the sum of the ages is going to be at most? So this is changing the inequality. So here we go. This is going to be less than or equal to 1595. Kind of wish they had used 1600. That way we would have just found the complement of this. But hey, just a little bit more work to get some practice. And this is going to go from 1595 less than, so it takes a trip to negative infinity. And again, we're going to go to a normal distribution of 49 times 30.9. Again, that's n times mu, and 9 times the square root of 49, which is going to be my standard deviation multiplied by the square root of the sample size. Okay, so our normal CDF is going to be from negative infinity, so negative 10 to the 99th power. I mean, in theory, you could put 0 there as well, but we'll stay consistent here. Then we'll go to our upper limit, which is 1595. And then it's 49 times 30.9, and 9 times the square root of 49, which is already typed into our calculator. So what's convenient about this when we go back to our technology is that a lot of this work is done for us. So we hit second vars, go to normal CDF. Okay, our lower limit is going to be negative 10 raised to the power of 99. And the upper limit is 1595. And then here we have our mu and our standard deviation. Go to paste. All right, puts all of that in there, which is really nice. And we get an answer of 90.0%. 90.0. All right, so let's write the answer down here. 0.900 if you want to be stylistic. Therefore, there is a 90% chance that the sum of x bar is less than or equal to 1,595. Okay, so now let's take a look here. In problem E, it says find the 95th percentile for the sample mean of 65 is our sample size. Let me indicate that because we are changing sample size here. Interpret the results. Notice down here we're also changing the sample size. Be aware, be aware, be aware. Okay, so for this problem, notice they're asking for the sample mean, not the sum, the sample mean. So the sample mean with the sample size bigger than 1 means that we need to find this for the central limit theorem. So when you do your problem or your inverse norm, because what we're trying to do with inverse norm is find the number that would give us the percentile. We want to type in the 0.95 here. We would put in our average of our group X, which is the same thing as our average, so 30.9. But in this case, we have to make sure that we're taking the standard deviation divided by the square root of the sample size. So there's our adjustment there, which is 9 divided by the square root of 65. And if we type this in, we'll get our answer. So here's our calculator. We're going to go second and go to vars and go to inverse norm. Oops, a little too far. Our area is 0.95. Our mu in this case is 30.9. And our standard deviation is 9 divided by the square root of our sample size, 65. And hit enter, paste, and this gives us that age that would give us the sample mean average at the 95th percentile. So that answer was 32.7. So 32.7 is our age at the 95th percentile. Which means that only 5% are older than this and 95% are younger than this. Now, it wants to find the 90th percentile for the sum of the ages. So we got to change this to red just so you can see consistency here. So we want to find this here. And so if what this asks us to do is if we added up the ages of 65 people, what would that total threshold be for the 90th percentile? So this is another inverse norm. I'll use red. Inverse norm. And in this case, we want the 0.95. But our standard, our average is not going to be just mu. It's going to be n times mu, because we not only want our average of 30.9, but we want 65 of them, because this is going to be the size of our group. And then instead of taking our 9 and dividing it by the square root of 65, we're going to multiply it by the square root of 65. And again, to reiterate, this is going to be our n times square root. Or sorry, the standard deviation. Get to the end of the video, get a little sloppy here. This is our standard deviation times the square root of n. All right, let's go type that in and see what we get. All right, so we're going to go second, and we're going to go to vars, and we're going to go down to invert norm. And our point, it's I wrote 0.90. Gosh darn it. Some of you noticed that right away, and you couldn't say anything. You just yell at the YouTube screen. It's 0.90. Read your own problem. All right, so there's 0.90. Okay, so now we're going to go back here, 0.90. And our mu is 30.9, but we're going to go to the end of it and put a times 65. And then we're going to go down here and change that division symbol to a multiplication symbol. And now we've got it. And this gives me an answer of 2 2,101. And this number right here, we can round down if you want to, and the reason why you'd round down is because you're not going to probably do any decimals or fractions when you do ages. So 2,100, and I'm sure actually if you do that you wouldn't be by the 90th percentile. So here you would round up no matter what, because if you went down to 2,101 and not 101.4 something, you wouldn't actually be at the 90th percentile, you'd be at the 89th, or with the decimal. So 2,102 years is my 90th percentile. For the sum of the ages. That's a sigma right there. So thank you very much for watching the video here and getting a lot of practice and learning a little trick when you get to sum of ages problems. Now you may not see any of these sum of ages problems in all of your homework, but if they're there, be sure to do those little modifications to your normal CDF to get the answer right. All right, thank you for watching.